Hello everybody, welcome to our science class. Today we are going to learn about a new chapter. Chapter number 14, Magnets and their Effects. It's there in your textbook, page number 212. Chapter number 14, Magnets and their Effects. Let us start the chapter. Yes children, now let us start the topic Magnets and their Effects. So, what do you mean by the word magnet? Magnet. The name magnet has derived from magnetite. Where? From the word magnetite. So, what do you mean by magnetite then? Magnetite is an ore. Magnetite is an ore. Okay. Then, what is that made up of? It is an oxide of iron. It's an oxide of iron with the chemical formula Fe3O4. Clear? Yes. Now, so this iron oxide, it is the most magnetic substance of all the naturally occurring minerals on earth. Clear children? Yes. So, now we are going to learn about the history of magnet. So, from where we got this magnet? What was the story? Okay. Now, a few thousand years ago, there was a shepherd boy named Magnes. Okay. So, he lived in ancient Greece. Who lived in ancient Greece? Then, Magnes take his sheep and goats for grazing to a nearby mountain. He always carried a wooden stick having an iron casting at its lower end with him. So he will have a wooden stick with iron castings. Okay. Now, one day the tip of the stick got stuck firmly to a large black stone on the ground. Clear? Then, after a long time, he managed to free his stick. So, after some time, the stick came out. Okay. Then, he discovered that the iron covered part of the stick was attracted by the rock. So, it was attracted by one specific rock. So, the rock was named magnetite. What was the rock? The rock was named magnetite. Okay. So, the rock was named magnetite after Magnes. After this person named Magnes. Clear? Then, where and all we are using these magnets? Magnets are used in telephones, televisions, washing machine, electric motor, electric generator and many other devices. Clear children? Yes. Now, let us learn about magnets. Yes children. Now, let us start with magnets. Magnets. What do you mean by magnet? A magnet is an object that can attract object made of substances such as iron, nickel and cobalt. Okay. So, magnet, we all know magnet will attract some objects. So, magnet will attract the objects which have iron, nickel and cobalt contents. Clear? Then, this property of a magnet to attract substances like iron is called magnetism. The property is called magnetism. Clear? Then, the force of attraction exerted by the magnet on these substances is called magnetic force. What I said? The force of attraction exerted by the magnet on these substances is called magnetic force. Now, let us see this magnetic force. Children, now we can see some objects just kept in the table. A piece of paper, pencil and then cell or battery and then wooden clip, coin, pen cap and safety pins. Okay. Now, I am going to show a piece of magnet. I am going to show a piece of magnet to the objects. Now let us see what will happen. So now I am showing this magnet above the paper, no reaction, above the pencil, no reaction, and then see how it's getting attracted. Is it not? Yes. Then let us try with the next wooden clip. No. Coin? Yes. So it is attracting with a force. Is it not? Yes. Now, pen cap? No reaction. See how it's getting attracted? Yes. Now, this is what about magnetic force. The force is said to be as magnetic force. Now, we are going to learn about this magnet and magnetic force in detail. Children, now we are going to learn about magnet, magnetic force, magnetic field and all. Okay. So, now about magnet. A magnet is an object that can attract objects made up of substances such as iron, nickel and cobalt. Clear? Then, this property of a magnet to attract substances like iron is called magnetism. What is magnetism? The property of a magnet to attract substances. To attract substances like iron is called magnetism. Clear? Then, next thing is about magnetic force. What do you mean by magnetic force? The force of attraction exerted by the magnet on these substances is called magnetic force. Clear? Then, the region around the magnet, where the influence of its magnetic force can be felt is called magnetic field. What is that? Magnetic field. So, this magnetic field can be represented by magnetic lines of force. It can be represented by magnetic lines of force. Now, let us learn about magnetic and non-magnetic substances. What do you mean by magnetic substances? The substances that are attracted by a magnet are known as magnetic substances. They are made up of iron, nickel and cobalt. These are some familiar examples of magnetic substances. Second thing is about non-magnetic. What do you mean by non-magnetic substances? The substances that are not attracted by a magnet are known as non-magnetic substances. Copper, brass and wood are some examples of non-magnetic substances. These are familiar examples for non-magnetic substances. Thus, nails and screws are magnetic materials, whereas wood shavings are non-magnetic substances. Non-magnetic substances. So, now we are going to learn about natural and artificial magnets. There are two types of magnets, natural magnet and artificial magnet. So, we are going to learn about first natural magnet. Natural occurring magnets are mostly found in rocks. Natural occurring magnets are mostly found in rocks. Children, now first let us learn about natural and artificial magnet. So, what do you mean by natural magnet? Objects that are found in nature exhibit the property of a magnet. So, the objects that are found in nature and exhibit the property of a magnet like attracting magnetic substances. That property is there naturally. Okay. So, that is why it is said to be, or it is known as natural magnets. It is known as natural magnets. People learn to make magnets from magnetic substances. Clear? These are called artificial magnets. So, second type of magnet is said to be as artificial magnet. What is this? They make people learn to make magnets from magnetic substances. These are called artificial magnets. So, as of now there are two types of magnet, natural and artificial. Clear? Then we are going to learn about properties of a magnet. Properties of a magnet. The magnet attracts objects made up of magnetic substances. It attracts objects made up of magnetic substances. The property of the magnet to attract the magnetic materials towards itself is called as attractive property of magnet. What is that? Attractive property of the magnet. The attractive property of the magnet can act through non-magnetic substances. So, this property will work in non-magnetic substances also, like wood and paper. For example, a magnet can move an iron nail placed on the wooden table. A magnet can move an iron nail placed on the wooden table. Clear? Yes. Now, let us learn about the next topic, that is poles of a magnet. Poles. What do you mean by poles? Terminals. Okay. Let us learn. The two ends of a magnet are called poles of a magnet. The two terminals or end are called poles of a magnet. So, there are two different poles, is it not? Either we can call poles of a magnet or magnetic poles. At the middle of the magnet, magnetic force is minimum. Usually in a magnet, the middle part has minimum magnetic force, middle part. Okay. So, it will be maximum at the poles or at the terminals. Okay. So, every magnet irrespective of its shape has two poles. I repeat, at the middle of the magnet, magnetic force is minimum. Then every magnet irrespective of its shape has two poles. If we are taking a magnet, it has two poles, the north pole and south pole. What are the two poles? The north pole and the south pole. The north pole of a magnet point towards the Earth's geographic north pole. Can you understand? Earth's geographic north pole when suspended freely. Clear? Then same thing in south pole also. The south pole of the magnet point towards the Earth's geographic south pole when suspended freely. As like north pole of the magnet points towards the Earth's geographic north pole, similarly here south pole of the south pole points towards the Earth's geographic south pole. South pole of the magnet points towards the Earth geographic south pole when suspended freely. Clear? Yes. Then it was discovered that if a piece of magnetite was freely suspended, in air, it always pointed to north to south direction. This is the directive property of the magnet which paved the way for creating navigational compasses. Clear? Yes. Children, now let us learn about magnetic axis. It is the imaginary line joining the two poles of magnet. Just now we saw the picture, is it not? So, what is that? It is the imaginary line joining the two poles of magnet. The axis of a freely suspended magnet always aligns in north to south direction. So, if it is freely suspended, automatically it will align or set in north to south direction. Clear? Then a magnetic compass consists of a magnetic needle. The compass consists of a magnetic needle. We saw it is there at the center, is it not? consists of a magnetic needle with the pointed ends mounted on a pivot above which it can freely rotate. The meaning of the word pivot is to turn or to rotate. So, when it is rotating, easily with that we can find the direction. Clear? Then, the north pole of a magnetic needle, that is differentiated with the red color. The north pole of the magnetic needle, red colored, always point towards the geographical north direction. So, red color part of the needle shows the geographical north direction. Clear? Then, therefore, other geographical directions can be easily determined. So, with the north we are finding out the rest directions and all. Clear? It is important for sailors and navigators in olden days. Why? When there was no GPS. Now we are having GPS. So, what do you mean by GPS? Global Positioning System. So, with this magnetic compass or magnetic axis, using this they can easily identify in which direction they were travelling. Clear? So, this is what about magnetic axis and magnetic compass. Now, let us learn about the next topic, that is separating the two poles of a magnet. Children, now we can never isolate the north and south poles by breaking a magnet into several pieces. They always exist as a pair in magnets. I repeat, we can never isolate the north and south poles. Separately we cannot isolate. By breaking a magnet into several pieces, they always exist as a pair in a magnet. Both the north and south poles will exist as a pair in magnet. Clear? Yes. Now, let us learn about attraction and repulsion of magnetic poles. So, now as you all know, a magnet has two poles, north pole and south pole. Okay. The north pole of a magnet repels the north pole of another magnet. So, here they are having two magnets. And they are keeping both the north poles together. They are just keeping nearby, and then the north pole of the magnet repels the north pole of another magnet. But if you are keeping north pole of a magnet nearby the south pole of another magnet, it attracts. Similarly, the south pole of a magnet repels the south pole of the another magnet, but it attracts the north pole of another magnet. So, in short, like poles repel, that is north to north or south to south. Like poles repel each other, while unlike poles, that is opposite poles, north to south or south to north, unlike poles attract. Clear, children? Yes. Now, let us learn about important properties of magnets. A magnet attracts magnetic substances. Such as iron, cobalt and nickel. So, these substances will be there in some objects. Those objects will get attracted by the magnet. Can you understand? Yes. Now, a freely suspended magnet always orients itself along north to south direction. Then, a magnet has two poles. As you all know, a magnet has two poles. The two poles where its magnetic force is maximum. At the end terminals, there the magnetic force is maximum. Clear? Then, opposite poles attract each other. Is it not? Just now we learned. Opposite poles attract each other, while like poles repel each other. Clear? Then, magnetic property can pass through now non-magnetic material. I repeat, magnetic property can pass through non-magnetic material like wood. If you are keeping a magnet over the wood, even there the magnetic property, the magnetic force is applicable. Clear? That's what. So these are some important properties of magnets. Children, now you can see the picture for magnetic compass. Is it not? Yes. So this magnetic compass consists of magnetic needle. Magnetic needle with pointed ends mounted on a pivot above which it can freely pass or rotate. Okay. The north pole of the magnetic needle, the red colored part, no? That's what the north pole of the magnetic needle, this red colored needle, it always point towards the geographical north direction. So the red color always shows the geographical north. Therefore, other geographical direction can be easily determined. Other geographical direction can be easily determined. So with this, we can easily determine other directions. It is useful for sailors and navigators and all. Clear? Yes. Yes, children. Now we are going to learn about methods of making magnets. Methods of making magnets. Making magnets. Magnets can be made from magnetic substances. Can be made from magnetic substances. The process of making a magnetic substance into a magnet is called as magnetization. Is called as magnetization. The magnets may either be temporary or permanent in nature. There are two types of magnet. What are they? They are temporary or permanent in nature. Then, temporary are those artificial magnets that lose their magnetism. What is called as temporary magnets? They are artificial magnets that lose their magnetism. Clear? As soon as that causes, that produces the magnetism is removed. As soon as it causes, it produces the magnetism is removed. Clear? For example, iron, nickel and cobalt, all these things are used to make temporary magnets. They will be mainly in temporary magnets. Clear? Next type of magnet is permanent magnet. Permanent magnet. Here, permanent magnet, artificial magnet that retain their magnetism, which has this magnetic property with themselves, is said to be as permanent magnets. Clear? Even after the removal of the cause of its magnetism. So, this magnetic property will retain on this type of permanent magnet even after the removal of the cause of its magnetism. Clear? Then, mixtures of iron, nickel or cobalt along with other substances. Not only iron, nickel, cobalt, along with other substances, all these substances are used here to make permanent magnets. So, children, as of now there are two different types of magnet, temporary and permanent. Clear? Then we are going to learn about the methods. So, there are two methods, single touch method and double touch method. So, now let us learn about single touch method. Yes, children, now let us learn about single touch method. Single touch method. You can see a magnet, bar magnet which is kept here. Is it not? Yes. Now, let us learn. Place an iron bar that has to be magnetized on a non-magnetic surface such as wood. So, they are having an iron bar. This iron bar is kept over the non-magnetic surface. Okay. Then, take a bar magnet and place its north pole. This red colored part is north pole. Clear? So, they are placing this north pole at one end of the iron bar. They are placing this at one end of the iron bar. Drag the magnet slowly on the iron bar from its one end to the other. So, this is the one end and this magnet is dragged from one end to the other end on the iron bar without lifting, that is dragged without lifting. Now, lift the magnet and bring it back to the starting position. You can see here the arrow mark, is it not? So, now from here to here they are moving, okay, and then that is lifted. Now, lift the magnet and bring it back to the starting position. It is rotated like this in this direction, and again it is back again to the starting position like this. You want to repeat for 30 to 40 times, 30 to 40 times with the same speed, Then remove the bar magnet. Then bring an iron nail near to the bar magnet and check whether it has become a magnet. If it is not getting attracted, then again you should repeat the process for few more times. Clear? So, this is what single touch method. So, at the end, if you are observing the bar magnet, the iron bar has been magnetized. It will turn to a magnet at the end. It will turn to a magnet. One of the end will occur magnetic north pole and the other end will occur magnetic south pole. Red color denotes your north pole and other end will occur magnetic south pole. So, this is what about single touch method. Yes children, now about double touch method. So, now they have kept two iron bars. They are using here two bar magnets. So, they are using bar magnets and that too it is of equal strength. They are using two bar magnets of equal strength to make a permanent magnet. Okay, so how they are making? Place an iron bar on a non-magnetic surface such as wood. So, you are keeping the iron bar over the wood. Place the opposite poles of two bar magnets at the center of the iron bars. I repeat, place the opposite poles of two bar magnets. Here, if you are keeping north side, it should be opposite in the another bar magnet. Place the opposite poles of two bar magnets at the center of the iron bar. Where you should keep? At the center of the iron bar. Clear? Now, slowly drag the two bar magnets on the iron bar in opposite directions. Now, it should be dragged on the opposite directions till the ends of the iron bar. Where? Till the end of the iron bar. Lift the magnets and move them through air to the center of the iron bar again. Now, repeat the process few times. Repeat this process few times more. Okay. Then, finally, the iron bar has been magnetized. Yes children, now you can observe the arrow marks even. So, they are moving this bar magnet in this direction and they are just positioning in the same position. Okay. And this bar magnet in this direction, okay, and then they are keeping here. So, they are repeating like this. Can you understand? Yes. Yes children. Now, we have learned, as of now we have learned double touch method and single touch method. Is it not? Yes. Now, let us learn about Earth as a giant magnet. Giant magnet. Here, the north pole of the magnet point towards the north direction. Is it not? The north pole of the magnet points towards the north direction and the south pole of the magnet points towards the south direction. Now, the Earth itself behaves as like a giant bar magnet buried inside it. Giant bar magnet buried inside it. So, now the magnetic north pole of Earth is a geographic south pole. Imagine an Earth picture and the magnetic north pole of the Earth. For the Earth, they are having separate magnetic north pole and magnetic south pole. Okay, the magnetic north pole of the Earth is located in the geographic south pole. Earth's north pole is located in the geographic south pole. Clear? And magnetic south pole is located in the geographic north pole. The magnetism of Earth is due to the movement of molten iron at Earth's core. Core means the innermost part. So, the innermost part of the Earth has molten iron. So, based on the movement of the molten iron, the magnetic property, that is the direction, the magnetic north pole and the south pole, they have been located. Clear? The magnetism of Earth is due to the movement of molten iron at Earth's core. Now, next thing is about preserving magnets. How to preserve magnets? If a magnet is dropped frequently or hammered or heated, it will lose its magnetism. Hammered or heated, it will lose its magnetism. It will get demagnetized. Clear? The phenomenon in which a permanent magnet loses its magnetism is known as demagnetization. I repeat, the phenomenon in which a permanent magnet loses its magnetism is known as demagnetization. Self-demagnetization is the phenomenon in which a permanent magnet loses its magnetic property when it is not used for a period of time. Clear? So, then next thing is about uses of magnets. What is that? Uses of magnets. So, some uses, credit cards and ATM cards have magnetic strip that stores information. They are used in medical diagnosis. Magnets are used in medical diagnosis. They are used in electricity generation. Then they are used in making storage devices such as hard disk. Clear? Yes children. Children, now an activity for you all. So, take two magnets and locate the north pole and south pole. Then try to keep north pole of one magnet with the north pole of another magnet. So, keep both the north pole nearby and see how it is reacting. Then similarly try to keep north pole of one magnet with the south pole of another magnet. Now, you will understand that like poles repel each other, that is north pole to north pole or south pole to south pole will repel each other, and unlike poles attract each other, like north pole to south pole or south pole to north pole. If you are keeping together, it will attract each other. Clear children? Yes. Yes children. With this, we have come to an end of this chapter. After watching the video, learn the chapter thoroughly so that you can understand well. So, take care. Goodbye.